Now we are going to quickly discuss how to scale a vector. The idea is very simple. If you start with a vector x of size n, then multiplying it by a scalar alpha simply scales each component by that scalar. In other words, each component is multiplied by alpha. The fact that we use the word scaling suggests there is a geometric interpretation. Let's look at an example. Here's a vector in 2D with components 4 and minus 3. If you add the same vector to it, which geometrically is the same as scaling it by a factor 2, you get the vector with components 8 and minus 6. So, the vector that results from putting the vector x head to toe with itself is a new vector that you can think of as 2 times the vector x. Another way of viewing this is to start with the original vector and stretching it by a factor 2. Similarly, if we look at the same vector and we scale it by a negative number, in this case negative 1/2, you get the vector that points in the same direction but has negative 1/2 the length. In other words, the vector points in the opposite direction and has half the length. So, to summarize, scaling a vector by alpha results in a new vector that is in the same direction as the original vector, but with lengths scaled by alpha.